Hey, hi all, welcome to the video. And in this video, we will look at how to handle NAs and why are they of special interest to not only R but to all programming languages, especially statistical programming languages. So the thing is, something that cannot be defined or not available or is blank or is missing, we normally replace these values with NA, and the simple reason of doing that is there are a lot of functions in built-in R that can handle that. We'll just look at what exactly that does that mean, and to get an understanding of what exactly an NA is, we will start with a very small example. Let's say we declare a vector S with values 1, 2, 3 and NA. If I just declare it and see what's there in S, so I will just see that S is a vector with 4 values, with the fourth being an NA. Now there are certain things that we can do with NA. Let's say I want to see if vector S contains an NA or not. So we can just do, is there an NA? So this is basically read as, is there an NA in S? So I can just do that and it will give me true at the position where NA is present. If I want to know what are the number of NAs in S, so I can just do sum of the logical vector obtained by S dot NA. Again, if I sum up a logical vector, it will give me the total number of true. So in this case, it will just give me a 1. Let's say if I want to know what is the particular position at which NA is present, so I can just use a which function, which is basically used for indexing operations or for a particular index where a particular condition is true. So if I do that, I will get 4. Now let's say if I want to have two vectors and arrange them or have them in a particular mathematical operation. So let's say I declare T, which itself has two NAs. Again, it is a 4 vector, it basically has 4 elements and two of them are NAs. If I add them up in S, so what will I get? Wherever there are NAs, irrespective of whether the other element is an integer or any other thing, it will give me an NA. So if I do uh, basically, let's say NA plus 2, it will give me 2. Sorry, it will give me NA. If I do 3 plus NA, it will give me NA. So NA added to any integer or numerical value will give me NA. So this distinction we have to keep in mind, and this is a very simple example of how we can see what happens when we do an NA based operation on a mathematical function. Now let's say S is a vector which has 1, 2, 3 and NA. If I just do mean of S, it will give me an NA because I have not specified how should I treat NA. Now there is an argument within mean function which is remove NA. If I assign it as true, then I will basically give the mean values of 1, 2 and 3, which is 2. And now we'll just look at a use case. Let's say there are a lot of columns within a data frame which has NA. The first thing we want to do is find the count of NA values against each column and then do certain suitable imputation against each. The dplyr is a very famous data package, and if we look at the number of data set available with it, there are 10 data set available with the dplyr package, and we'll be working with the Star Wars data package. I just assigned Star Wars to df, and if I look at the column names, there are you know 14 columns in that, and if I just look at the first few records of the first 4 columns, so basically this is it. If you look at the fourth column, there are two NA values in the first 6 records. Now what we are going to do is we will iterate or loop through each column, and then we'll look at the total count of NAs across each column. So what I'm doing, I'm initializing a list first, and then I'm going I'm going through each columns in df. Now let's say I put I as let's say hair color. This is the fourth column. If I want to get the total number of or total count of NA, basically I will do an is.NA, which will give me a logical vector, and then I will sum it up. So if I do that, I will get a total of 5. Then I will create a data frame which is temp.df, which has two columns with the variable name and the sum of NA. If I just do this, see, I've got the variable name as hair color and sum of NA as 5. And then I will assign this data frame to a list which has its own individual element in the form of a column name. So if I do this, sorry, temp.df is not defined, just give me a second. See, now if I look at what's there in L1, so L1 currently has only a single element corresponding to hair color column, and within that there is a data frame with two columns, variable and sum of NA. Now if I do this operation across all the elements using the for loop, I will get a list with individual elements corresponding to the column names. These individual elements in turn have data frame within them. Now what will I do? I will try to row bind all these individual elements within L1 into a single data frame, which is df underscore NA. If I look at NA, if I look at the df underscore NA, it will basically give me the total number of NA values within each column. Now in the next video we will look at suitable imputation techniques or very naive imputation techniques that we can do, to just clean up the data.